Hey there everyone, this is Anthony. Before we get started with this video on the perfect square trinomials, I wanted to let you all know that remind you that if there is a topic that you're looking for more explanation and examples on, leave a comment below on whatever that topic may be, and I'll be happy to make a video and upload that for you. All right, so without further ado, we're going to take a look at perfect square trinomials. And perfect square trinomials, this is our third factoring technique. The first one that we saw was the GCF, or the greatest common factor. The second one that we saw was the difference of squares. And for the difference of squares, let me write this one out first so that we can compare with what we're going to see right now. So difference of squares, it looks something like this: x squared minus y squared. And we were able to factor that to be x minus y, x plus y. All right. And so in this video, we have the perfect square trinomials. And the way that this is going to look, it's going to look slightly different. All right. And the form that we're going to see is this. All right. So the x squared and x squared match, the y squared and the y squared match, but we've got this extra term in the middle. For this, we're going to call this part A, perfect square trinomials part A. There's going to be a part B where we're just going to change this sign right here. And this right here, we may be able to guess what it will factor to, but I'm going to write this out for you, and then we'll take a look at some examples. We'll discuss, we'll prove that these are equal to each other. So very, very similar. We're going to be able to take the square root of the first term. We're going to be able to take the square root of the second term, but there's actually two terms that are the same: x plus y times x plus y. And this is the factored form for the perfect square trinomial. Let's verify this. Let's just distribute. Remember, if this is raised to the second power, we can copy and paste what's inside of this many times. Let's distribute. So first term times everything in the second parentheses. X times x is x squared. X times y is times xy is plus xy. Now we're going to distribute the second term with every term in the second parentheses. So y times x, and then y times y is y squared. Notice that when we're multiplying x times y and y times x, these are the same thing. And because we're adding, they are like terms. And we see that this does indeed match this. All right. So let's take a look at some examples. We'll get some practice with how we're meant to factor these when we do see this pattern. So let's say we have 16x to the second plus 8x plus 1. All right. And something that I'm always on the lookout for is whenever there are three terms. As you can see with the difference of squares, there's only two terms, but there are three terms. They're all positive, so we're thinking, okay, this looks really, really similar. Let's see if I can take the square root of the first term, and let's see if I can take the square root of the second term. The square root of the first term, 16x to the second. All right, remember we can rewrite this as 4 squared, and this is also x squared. Because each of these has the same exponent, we can rewrite it as this. And notice because the index matches the exponent, our answer is just whatever the base was equal to. All right, so we do get a nice whole number with a nice variable with a whole exponent. Let's take the square root of the last term. Well, this is equal to 1 squared. The exponent matches the index. This works out as well. Now, the real thing that's going to tell us whether this applies for the perfect square trinomials factoring technique is if we take the product of the first and the last term once we've taken the square root, and if we multiply it by 2, if we get this. All right, so let's try that. 2, we're doubling the product of x, which was 4x. It's once we took the square root of the first term. And we're going to multiply it with y. 2 times 4 is 8, times 1 is 8, x, there's no other variable, and we get 8x, which also matches here. So now we know that we can proceed, and our answer will simply be this. Our x that we found is 4x. Our y that we found is 1. We have a plus in this case because both are positive. And we square it. And this is our answer. All right. Let's take a look at another example. And this is actually going to be the perfect square trinomials part B. And it's just one slight difference between this form. It's going to look like this. X squared minus 2 times xy plus y to the second power. Now, the reason why the third term is always positive is because we're squaring something. Whenever you square it, it will always be positive. In the case of the middle term, we're just multiplying it with a term that's different. X and y are different from each other, and then we're multiplying them by 2. So it's possible that's positive, it's possible that that is negative, but the last term will always be positive. All right. And this will be x minus y to the second. And if you want to prove it that this is equal to this, we just do the same thing as we did here. But let's take a look at an example. Let's say we have x squared. You know what? Let's make it 4x squared. Minus 20x plus 25. Okay. And so let's see if this fits the form. We're going to take the square root of the first term. The square root of 4x squared is equal to 2 squared. And then we have x squared, just like earlier. So this is 2x all to the second. Index matches the exponent. And so our first term is 2x. Our last term, 25. Let's take the square root of that. This is equal to the square root of 5 squared. Index matches the exponent. So our answer is 5. Now let's check the middle term here. We are going to double the product of the first term with the last term. And we get 2 times 2 is 4, times 5 is 20, times x, 20x, which is what we have here. All right. So let's put this all together. First term, second term. Oops, sorry, this is the middle term. This is our last term. So we have 2x, and then minus, because this is a minus here, and 5, and we square this. Now, let's quickly check. Let's verify that these are equal. If it's 2x minus 5 quantity squared, whoops, we're going to rewrite this not once but twice. Let's distribute first term by everything in the second. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Let's distribute the negative 5. Negative 5 times 2x is negative 10x. Negative 5 times negative 5 is positive 25. Combine like terms. And we see that this is equal to the original. All right, so these are the two cases for the perfect square trinomial. Look for three terms. The last term will always be positive. If the second term is positive, you know that our answer will be positive, x plus y all to the second. If our middle term is negative, x minus y, all quantity to the second. So I hope these two examples helped you. If, like I said, and in previous videos, if you have any questions, leave them in the comments. I'll be happy to answer them. If this helped you, share it with someone else. And I hope you have an awesome day.